Hi guys, welcome to Learn with W3 Schools. My name is Dr. Shan and today we're going to start R programming language tutorial using W3 Schools website as a reference. Now R is a programming language and it's a great programming language that is used for statistical analysis, statistical computing, graphical representation, analysis of data, visualizing of data and whatnot. So it's a very technical and very in-demand language, especially nowadays with the advent of AI. This language is becoming more popular nowadays using the main features that it hosts about analyzing the data in various different ways in graphical to table form. So we're going to explore this in this complete tutorial. This is going to be a large basic course where we'll cover all major concepts of R using W3 Schools as a reference. Okay, so without further ado, let's begin and start learning R programming. If you're here for the first time, still haven't subscribed though, please do subscribe. It helps us a lot and it motivates us, gives us some confidence in working more tutorials. Do let me know in the comments if you have heard about R before or if you're already using R for that matter. Okay, so let's begin with R programming language. Now, first of all, let's open up W3 Schools website and head on to the R tutorial page. It is an amazing website. It uses the references very wonderfully well. So we're going to delve into it and cover all major concepts from it. Now, the first thing that you start to see on R programming language is that introduction homepage on W3 Schools website. Now, what they're telling us is that R is a programming language. So for that matter, thank you for telling us. Then R is often used for statistical computing, graphical representation, and analyzing of visual data. That's what its primary main purpose is. But we're going to explore what exactly it can do later on. Okay, so we're going to use this website and we're going to explore all the examples given by W3 Schools, and we will see how they are used to analyze the data and represent the data in various different forms, especially using the graphs as well. So W3 Schools has a very nice tutorials and examples as built in. So we're going to explore those examples, see how examples are working, changing the values, and see how example goes one by one, word by word, topic by topic. Make sense? Perfect. So let's get into the introduction section. Now, what exactly is R programming? Well, R is a programming language used for statistical computing, okay, and obviously graphical representation of the data. So you do analyze of the data and then you graphically represent it in various different forms. It's most commonly used to analyze and visualize data. That's why it is more amazing, more popular. Wherever you need to analyze and visualize your data, you have to use R programming, and there's nothing more better than that. So that's why the main purpose is, and we try to go and explore all this using these topics given by W3 Schools. Now, why use R as compared to any other languages? Well, there are many prominent reasons for that. First, it has great resources for data analysis, data visualization, data science, and machine learning. So if that doesn't pull you into R programming, well, nothing else will. If you are a data analyst or you're working in machine learning and data science, R is your go-to language because it can do so much things for you very easily and conveniently. It provides statistical techniques such as statistical tests, classifications, clustering, and data reduction. It's easy to draw graphs in R like pie charts, histogram, box plots, scatter plots, etc. using your data. So we have a data and then you can very easily plot various different graphs for your research work, for your analysis, and whatever application you're working on. It works on different platforms like Windows, Mac, Linux. It is an open source and free. That's something that we always love. Any language that is open source and free to use has a huge community as well behind it because, again, it's open source. And then it has many packages and libraries and functions that can be used to solve various different problems. So that's why the key thing is that we use it for our data analysis, and having this, being able to draw various different graphs based on our data, just is wonderful thing. So let's get started and explore the basic syntax of our programming language. Well, first thing is first, how do we install R? So in this example, I will be using W3 Schools built-in R setup, and we're going to explore the R programming using the W3 Schools on website, but you can install it on your PCs as well. So all you need to do is go onto the cloud.rproject.org and download the latest version of R for whatever operating system you're using. When you have downloaded and installed R, you can run it on any computer. That's hopefully as simple and easy as it should be. I will try to post a separate video of how you can integrate R with your VS Code. As you know, most programmers tend to nowadays prefer VS Code. It has many extensions and makes life much more easy. Yes, you can customize R with VS Code as well. We'll talk about that later on. But as I said, primarily we will be using W3 Schools on website. We'll click on R, try it yourself, and it has a basic code, and we can click on it and run it. So if you don't want to install it, don't want to get into the hassle of it, just want to understand how R is working, what it is. So this will be very easy for you without any installation. Just use the W3 Schools own built-in R compiler, and you can run the code very easily. Make sense? Perfect. Let's go into and try and explore the syntax of R now. Okay, well, the R syntax basically means that how we write the R programming. So to output text in R, we use single or double quotations. The first thing to understand is, obviously, if you're coming from any other programming language, this would make sense. So if you need to print something, you just write hello world in inverted quotations and it will print the content in your output. So that's it. So there's no prefix, no code, no functions up till this point. If you are in R, just open up the console, and if I just write simply hello world within inverted quotations, it's going to print here. And obviously it's just printing the line numbers here as well. Okay, make sense? See how easy it becomes to work with R. To output numbers, you just type in the numbers without quotation marks. So if you want to type in 5, 10, 25, just write this in the R interface. In this case, 5, 10, 25 I've written here, and then you will find that it just prints the values here. So 1, 5, 10, 25 based on this thing, outputs gets printed. So no other functions, no main functions, just you can go with that. So congratulations, you have just used your first R programming language. Wonderful, right? So this is how simply you can get started with printing R. But then we have something called a print function in R. Yes. So like other programming languages, we have prints. So unlike many other programming languages, you can output code in R without the print function. So if you just write the strings, you can easily print it. We just shown you. However, R does have a print function available if you want to use it. So this might be useful if you're familiar with other programming languages such as Python or Java, C# or any other languages. Python specifically uses print. If you're coming from Java, we use system.out.println. If you're coming from C++, we use cout. In R, we use print method. So you can use print hello world as well. So instead of just typing in the string, you can use print hello world and it will again output the same thing, print output on the console. But do remember that you can do it without the print function as well. Okay, and there are many times you must use print function to output the code. For example, when you're working with the loops, which you will learn in next sections, you will be required to use the print function. So if you just use the X value here, it will now work fine. Okay, we'll just create some problem. So better to use print function in from start to end, just makes life much more easier, even though knowing that you can do it without it, because at some places print is necessary. So it's up to you whether you want to use print function for the output. However, your code is inside the R expression, inside the curly brackets, like the example above. Use the print function to output the result. Okay. So since the code is inside the brackets, you need to use the print function. So just be careful about that. So that's the first part of the syntax. Let's talk about comments. Well, every programming language has comments. So does R. Like every other language, comments are basically instructions to the compiler that please ignore this line. Okay, this means that do not print or execute this line of code, just comment it out. It's just ignored by the compiler. So comments can be used in R to explain your code, make code more readable, give some explanation, what's happening in the code and whatnot. And to do that, we use the hash sign, same as Python, by the way. So if you're coming from Python, you might be familiar with the hash sign. So when executing the code, R will basically ignore this line. Okay, so whatever precedes after this hash sign will completely be ignored by the browser, by the compiler, sorry. Okay, so when we execute our code, you will notice that anything that you write inside the comment is ignored and only the main statement is actually executed. So this line is completely ignored by the compiler. Okay, so whenever we need to use comments, we use the hash sign. This will just simplify much more things. Obviously, this hash can come in front of the line as well. So you can write in front. So this, up till this point, the code will execute. After this is commented out. Okay, anything that comes after the hash is completely ignored. So whether you write it before a statement, after a statement, in front of a statement, just makes sense. Yes, if you write it first, for example, if you execute this code and see this, so the comment is ignored at this point. But if you execute and you write this line, Control C, if I print it in front of it, now because this line is also coming after the hash sign, so everything after this is ignored. So even though we have a statement here, even though you can write print function here, if you write a print function here, still this line will be ignored, even though we have a standard code here. Why this is ignored? Because again, we have a comment. So anything that comes after hash is actually ignored. So anything after, whether it's after this statement, before or anywhere. Yes, anything if it's before this, before the hash sign, that get printed. But anything after hash, completely ignored. So keep this thing in mind. So this is a simple way of comments. If you need to use multi-line comments, well, again, same as Python, we use multiple time hash. Okay, so you can use hash multiple times to write a detailed comment about some code or some instructions, or just sometimes commenting out certain piece of codes just to test and debug some things. You can use hash as many times as you want. Everything you write inside comments is ignored. Make sense? Wonderful. Let's go on to talk about variables now. Okay, so now variables are basically containers that you use to store the data. Okay, so in R also same thing goes. If you are coming from another programming language, you might be very familiar with it, but if you are coming to R for the first time, do note that we use something called variables, which basically are containers, means they are able to store data values. So we have a data value, we don't use it directly. In fact, we use the containers called variables to store those data values. Okay, so R does not have a command for declaring a variable. A variable is created the moment you first assign a value to it. So to assign a value to a variable, we use this arrow function. So we use an arrow, less than sign and minus, okay, if that's what makes sense. In other words, a reverse arrow sign to assign a variable to a value. To output or print a variable value, you just type in the variable name. So for example, we have this code here. Now what's happening here is that we have a string called John. We are assigning John to this variable called name. Now notice there is no prefix here, means there's no data type specifically specified what type of data it is. It's just a variable name, arrow function, and then a John. We call it an arrow, makes life much more easy, but it's actually less than sign with minus. So makes a reverse left hand side arrow. Okay. So this is what it's doing. Even if you are using an integer number or any other number for that matter, you use a number value, use an arrow function, and then you require a variable name. A variable name can be any name as long as does not have a space or it does not start with a number. That's 2-3 main basic rules that we follow. So you cannot start a variable name with a basically number. Again, we talk about this in variable name section, but do keep this thing in mind though. Okay, so this is how we declare a variable in our programming language. In other programming languages, we typically use equal to sign. Okay, most programming languages do prefer that, but R, it just says, I want to use a different sign. So it uses this reverse arrow symbol, less than, minus, and then we assign a variable. And then in order to print it, you just type in the name and it will print the value John, or you can just print in the age, it prints 40. Remember, we can use this inside the print function as well, or you can just type in the variable name, since we know that print function is not a mandatory in most cases except in some. Okay, now so from the above example, name and age are variables while John and 40 are basically values. So to keep these two terminologies in mind, these are values, this is variable name. This variable name now has this value. So whenever we call the variable name, it will print the value. So this behaves like a container, it holds this particular value. Okay, make sense? Okay, so in other programming languages, it's a common to use this equal to operator, but in R we use this less than sign. Okay, so if you scroll down, print output, again, sorry, just one main statement. However, this line is preferred, but you can use equal operator for that matter as well. Okay, so just keep this thing in mind, but it's preferred that you use this less than most commonly. So that's why most common examples throughout this, we will be using this arrow functions. So now printing output. Okay, how do we print output? So to compare to other programming languages, you do not need to use a function called print or to print out the variable's value. You can just type in the variable name. So since we only declare a variable here, and then in order to print it, you can just type in the name and it will print the value. There we go. So now what we have is we created a variable, we assigned it a value called John Doe, and then we just use this name variable here without any print function or anything. So what this is going to do is it's going to print the output on the console, whatever the value is stored in this variable. Okay, make sense? Yes. Similarly, however, R does have a print function and you can call the name inside the print function as well without the inverted quotations marks. Because if you use inverted quotations, it's now going to think that this is a string and it's going to print this string as it is. Okay, so it's going to print the name. But since we want this to be behaving as a variable, as a container, so no inverted quotation marks, we just write the variable name as it is and then it's going to print the value. Okay, so there are times you must use print function to output the code. For example, when you go using it within the for loop, we just talked about this in a moment, so do keep this thing in mind. So if you are printing the value of x, you must use the print function because it uses the block and it needs to understand what's happening here. Okay, so it's up to you whether you want to use a print function or not, but most preferably its print function is recommended in certain situations. So if you're coming from other programming languages, you might find things much more understanding if you use print function within the R. Better. Let's talk about concatenating elements. Okay, now what do we mean by concatenating elements? By concatenating elements means combining two things together in the output. Okay, so you can concatenate or join two or more elements by using the paste function. Okay, to combine both text and a variable, R uses a comma, and then we combine them together. This is like a concatenating operator that combines two things together. So for example, we have a text, again a variable name, arrow function to assign a value, and the awesome becomes a value itself. So we have a text that contains this value awesome. Then in order to use this with another string, concatenation here is, notice there's no print function here. We use a function called paste. Paste R is a string, comma, text. What this is doing is it's combining this variable's value with this string. Now, if you're coming from other languages like Java or C# or C++ or Python for that matter, we use the same print method to do this operation. In R, it's using a separate function to do this concatenation called paste method. Okay, so when you execute the code, you would see that we use a paste method, and then it takes the string, comma, combines, because this is like a concatenation operator, and it joins it with the text string. So the output is R is awesome. Okay, so R is awesome means R is from string A, and then the comma from awesome word is concatenated as a string B or a value B. Okay, so paste, keep this thing in mind. Whenever you're concatenating, combining two values, you can use the paste method. You can combine two variables as well. So you can use variable 1, comma, variable 2. In this case, text 1, comma, text 2. So it's automatically going to take the content from this one, comma, concatenate it with this value. So it's print R is awesome. So you can concatenate it two or more values using this comma operator. Okay, then you can use the plus as well, but when you use plus, it works as a mathematical operator. So if you have value like 5 and then value like 10, and then you use plus operator, is going to do mathematical calculation and just add these two numbers together. So this becomes our mathematical operators. So if you're trying to combine a string and a text, do keep in mind this is going to generate an error. For example, if I have a num5, which is again a number, and then I concatenate it with or add it with a string. Okay, so this is generating an error because this is of a different type of data. We're going to talk about data types later on, but this means that this is a number and this is a string. I cannot do a technical calculation on these two things together, so we generate an error. Okay, multiple variables. Okay, what do we mean by multiple variables? Well, multiple variables means having multiple variables assigned the same value, okay, or declaring multiple variables on the same line. R allows us to assign same value to the multiple variables within one single line. How do we do that? So for example, we have variable 1, arrow function, variable 2, arrow function, variable 3, arrow function, and the value. So now here actually this is the value. These three are behaving as variable containers. Why we may use this? Sometimes we need to initialize multiple variables with a default value. Okay, so that all variables have initial default 0 value or something of that sort, and then later on we want to use it. So to declare and assign multiple variables same value, we basically can use this. Again, this happens in all programming languages. The only difference is we use arrow functions here. So if you print this function, okay, so if you print this function, you notice that all three variables print exactly the same value. So variable 1, variable 2, variable 3, all are printing orange because the same variable or same data has been assigned to all different variables. Okay, and this is what we mean by assigning multiple variables. Let's talk about a little bit about variable names. What kind of names we can use to the variables? As already mentioned, that variable names basically means that what type of name we can have, and the names should not have spaces. But it's a very common practice to come up with certain other characters within variable names. So knowing some rules or ground fundamentals that what names I can use as a variable or not is quite important to know in your programming. Okay, so yes, variable names are also sometimes referred to as identifiers. Okay, because they identify the value that's being stored there. So do have that thing in your mind. So a variable name can have a short name like X or Y, single character, or more descriptive like age, car name, total volume, etc. Rules for our variable names are quite simple and straightforward. Let's explore them. A variable name must start with a letter and can be a combination of letters, digits, or period. Now, here the key thing is it must start with a letter, meaning that your variable name cannot start with a number. Okay, so it cannot be followed by a digit. So make sure you have that. If it starts with a period, it cannot follow with a digit. So if you use with a dot, you cannot use it with as a number as well. Okay, so here are a few examples with the legal names, but let me just read through these. So a variable name cannot start with a number or underscore, made sense. Again, we have already talked about this. The only difference is if you're coming from Java or if you have studied Java or not. Java does allow underscore naming, so does Python. But according to this rule, a variable name cannot start with a number or an underscore. In R, you cannot start with an underscore. Number, understandable, it's across all programming languages, but underscore is something quite unique for our language. Means that you cannot actually use underscore as to start as a first character in a variable name. Variable names are case sensitive, so age are two different variable names. So if you use age as a small letters with a capital A, these two becomes completely different to each other. Or if all letters are different, all these three are completely different. So do keep this thing in mind. Okay, and then obviously we don't use reserve words as a variable names as well. We will talk about reserve words as we explore them later on. So here are for few legal variable names. You can use my var, you can use my underscore var, you can use my with a capital V, which this is called a camel case, a variable naming where the first word starts with a small, the second word's first letter starts with a capital. So make it more readable. You can have all caps, you can have variable number, we can have a variable starting with alphabets and a number, making sure the number is not the first character. And then you can also start with a dot. Even though if you start with a dot, then again you cannot use a number here. Okay, the rule was quite clear. Illegal names, again, you cannot start with a number, you cannot use minus, you cannot use space, you cannot start with an underscore, you cannot use an @ sign, you cannot use a reserve word like true or false. If some words are reserved, you cannot use them as well. So these are all illegal names, you cannot use them. These are all legal names, you use them. So it's good habit, a good practice to know what kind of variable names you use and what variable names are there that are allowed. Okay, make sense? Perfect. So we have already discussed about the basics of R, why is it important. We have gone through syntax, comments, and variables. Today, in this session, we're going to talk more about the data types, numbers, and maths. What exactly are data types? Now, in programming, data types are quite important. Basically, data types define us that what type of data we are using in terms of whether it's an integer number, whether it's a string, or whether it's a character, or whether it's a decimal number called float or double. So it defines the system. It tells our memory and processor that what type of data we are actually operating on. So that's what basically the concept of data types comes into play. Variables can store data of different types. So whenever we have declared variables previously, they can store actually multiple types of data. In different types, you can do different things. Every data type has its own specifications and operations that you can do on them or cannot do on them. Okay. So in R, variables do not need to be declared explicitly. In R programming language, you can declare a variable, but usually you don't need to do that explicitly. You just decline a variable and assign a value to it. Based on what value you assign, it automatically gives them the data type implicitly. Okay, but you can do this explicitly as well. Okay, so we have already seen that, okay, this is a variable, we use an arrow and then we define the data. So what this basically means that it automatically will go and say, hey, I'm going to use 30 as an integer number and this variable becomes of type integer. Or if you define a string within inverted quotations, this will become a string character and will be automatically assigned to the string. So implicitly, it will automatically know what type of data you are working on. R has a variety of data types and object classes. You will learn much more about this as you continue to grow about R and as we cover more topics in detail in next sessions. But the basic type of data, let's cover them quickly. What exactly are those basic types of data? So in R, we have something called a numeric data type, which basically means number form. We have integer data types, which are basically simple integer numbers. We have complex data types, i.e. that have a complex notations with them. We have a character data type, i.e. a string. In more commonly, we call them in other programming language string, but in R, we specifically refer to them as characters. And then we have a logical data types, i.e. known as Boolean data types. Okay, so these are basic types of data that we use within R. For example, if you come here and you declare a variable as 10.5, this is known as a numeric data type. In typical languages, we call them float or double. 10.5 is containing a decimal value, again is known as a numeric value. Similarly, an integer basically means an integer data type and it precedes with an L. L is just as an indicator, it indicates that, hey, I'm using an integer type of data. Not compulsory, but it's usually written there. So if in previous example, you've seen that we did not write L, still it's considered as an integer number. Then we can use complex numbers that uses, for example, 9i plus 3. This becomes a complex notation. So I power to 3. Then we have character or a string data type that is usually inside an inverted quotation marks. For example, R is exciting. Yes, it is. and then it uses this string data type to be assigned automatically to this variable. And then we can have a logical, or in a common term known as Boolean data types, means you write true or false. This is only a type of data that contains two values only, either true or false. That's it. Okay, and then we use a class function to determine which type of data it is. So if you execute the code, you will notice that it gives us the type of data we are using. So the class function actually here is defining us that what type of data we are using. So in other words, we try to find out that, hey, I have a data, I don't know what type it is. So you use a class function, it tells you, okay, this is the type of data you are basically using. And it will give us a response, whether it's a numeric, integer, complex number, character, or a logic word. Okay, make sense? Wonderful. Huh? Let's go further. So you will learn much more about these individual types in upcoming chapters though as well. Let's learn about numbers now. Well, our numbers are simply numbers, right? But there are three types within these numbers. Means that we have a numeric type, which is again the decimal value. We have an integer number, which basically means any whole number. And then we have a complex number, which again means you use complex notations like I power to e, or I power to 1, or e power to x, or so on and so forth. Exponential notations, as we sometimes call them in mathematics. So variable numbers of types are created using value you assign them to them. So basically whatever value you assign them, its number is implicitly automatically assigned to it. So we have 10L, which basically defines as an integer number. If you use points or decimal values, it becomes a numeric. And if you use I notation, it becomes a complex number. A numeric data type is the most common type in R. It contains any number with or without decimal value, like 10.5, 55, 706, all of them are considered as numbers. So for example, when you use 10.5, still a numeric value. You use 55, still a numeric value. So when you print the values of x and y, it prints the value whatever has been stored in those variables. And remember, we have already talked about it. You can use x or y directly, it will print the value, or you can put them inside print method. To find out what type of data is in this xy, we use the class function. Then we have integer type. Integer type are specifically a numeric data without any decimal numbers. So this is used when you want a certain value that will never be used as a decimal point. Okay, so to create an integer variable, you just have to use this L symbol as a postfix. So at the end, as a postfix, you basically use this L symbol indicating that this is an integer number which will be assigned to this x. Hence, it will explicitly know, I'm creating an integer number though. So whatever number you're using, just preceded with its capital L, it becomes an integer number, and then you can print it out. If you execute the code, you will see that first, if I use x and y, it prints the value without the L. So do keep in mind the L is just an indicator telling the R compiler that I'm using an integer number. As an output, this L doesn't get printed at all. So you don't have to worry about that, how to remove the L in the output. So when you print the output, it just prints the integer number. Then you can use the class function to determine what type of data it is, and it will tell you, hey, these are integer number because we have used L here explicitly. Make sense? But let's go forward. So now, if you use complex numbers, well, complex numbers is written within I as an imaginary part. Okay, so we write x with the arrow function 3 plus 5i. I becomes the complex number imaginary notation, or you can just simply write 5i as well. When you print the value, it prints the value, and you can find the class, using the class, you can find the data type as well. So here you go. So now check out the output of this thing. When you use x and y to print the complex number, it prints the complex number as it is, 3 plus 5 to I. If you use just 5i, it will again use 0 plus. So it will precede or do this prefix as well, because again the notation has to be on the power 5i. So that's why this imaginary number is printed with 0 plus 5i. So always keep in mind this thing as well. This can get sometimes a little tricky. When you use 5i, it basically will use 0 plus 5i as a notation. If you use the number here as a denominator, then it works fine for this. So x plus y, x comma y, you print the values, it prints the output. You use the class function to determine the type of the data it is. Okay, the type conversion. Now, here's the tricky part here. Sometimes you use or declare a data, and then you need to convert one type of data into another. By that we mean that, for example, you declare a variable as a numeric, but then you want to change it to an integer number, or a complex number into an integer number, or an integer number to complex, vice versa as they go. To do that, we basically use certain functions, such as these ones given. Here, we are using function as.numeric to convert data from integer to numeric data type. We can use integer value which will basically convert any numeric into a type integer, or you can use complex, which will convert any number into a complex form. How do we do that? Let's see an example with it. So here you can notice the example. We have x, we declare a variable with 1L, which becomes obviously an integer number. Then we have y, which is a numeric value. When you convert this from integer to numeric, we use a as a resultant variable. So the answer is actually saved inside this variable. We use as dot numeric, and then we pass it the value of x as an argument. What happening now is that it takes this integer number, processes it, and then returns a numeric value and assigns it answer to this numeric variable. So this behaves as a function. Okay, inside this as class, we have a numeric function. This numeric function will basically convert, or what we call cast, x into a. Similarly, we has as integer. What this is going to do is it's going to take this y variable, which is again a numeric variable, and then it's going to convert this numeric value y using this as dot integer function and assign the answer to the b. Hence, if you check the value of a and b, it's going to return the resultant value, which is again numeric and integer. So as you can see, now we have numeric and integer. So initially we declared them as integer and numeric, but then using these functions, we can convert any type of data using as object dot numeric, its function, and then we pass it a value in terms of an argument. What this is doing again is it is converting the data from one type to another. This is called what we call a type conversion. Okay, make sense? Let's talk about math now. In R, you can use operators to perform common mathematical operations. Okay, and then obviously this is the major purpose. We use R for data science and analytics and everything. So math operations are quite commonly used. So one common operation you already know, I think from class 1, plus operator. It's obviously going to do 5 plus 10 and add them together or subtract them together. And then there are various different built-in functions as well. Obviously, you can use all mathematical signs, plus, minus, divide, modulus, remainder operators in ease. Okay, built-in functions basically perform certain calculations on them. So, for example, we have a maximum function and a minimum function. What they're doing is it's determining, if a max function is used, it determines amongst the number or the list of numbers that you have provided, which value is the maximum. Okay, so which value among these three is the maximum. Similarly, if you use the minimum function, it's going to determine that amongst these three values, which value is the minimum one that we are supposed to use. Okay, if you check the code, you would find that it returns the maximum number for the max function and the minimum value from the minimum function. So using functions, we can determine some things as well in mathematics, or in using R, using some mathematics. Similar to minimum max, there are tons of other methods that you can use. Some of them are, for example, SQRT. Makes sense, right? It finds the square root of a number. So whatever a number or a variable you pass it here, it will determine the square root and return the answer. The ABS function returns an absolute positive value of a number. So if you use a minus sign, it's going to return an absolute positive value. You can use value functions called ceiling and floor. These functions rounds a number upwards to the nearest integer, or the floor function rounds the number to the nearest lowest integer. Okay, so for example, if I use ceiling 1.4, it's going to round it off to the upward nearest value, and then similarly floor will give us the lowest value. So when you round it off, 1.4 now becomes, the highest value becomes 2 because it rounds up upwards to its ceiling, and the floor subsequently will does the reverse and it rounds down to its lowest value. So it becomes 1.4. Oh, sorry, just 1.4 becomes simple 1 value. Okay, so whenever we need to do rounding off to an upper or lower values, we basically use ceiling function and floor function. They just handle the entire rounding off automatically. Similarly, there are many other functions that you can use. If you just check out the ceiling R's basic tutorials and reference lists provided at the bottom, you can find many data and values here. Okay, let's talk about strings now. Well, a string are used to store text. So anything you write inside inverted quotations will basically work. In R, you can use double quotation as well as a single quotation marks to indicate a string value. So for example, when you use double quotations, it's also legit, also allowed, or you can use a single quotations as well. Works perfectly fine. They basically mean the same thing, that we are using a string literal. How do we assign a string to a variable? Again, we have seen that example. We have to declare a variable, use an arrow or less than sign minus, and then we assign it a string. Then you print string variable, it prints the entire string to us without the inverted quotation marks. You can use multi-line string as well. To do that, well, we just simply start with an inverted quotations, write the multiple lines of code, close the inverted quotations. And when you print the value, it prints the whole string, not just the first line, it prints the whole thing. Yep, so you can see this now, it has the entire string. The only key thing is that it prints in one single line and it adds this backslash n here in the output. Where did this come from? This came from here. So when you moved backslash n here, pressed enter, it will save this enter as a character. So that character has a symbol called backslash n, which technically is known as escape character, and it will just print out this symbol on the output itself. So be aware of this. Okay. Then, however, note that R will add the backslash n at the end of each line. This is called escape character, and the n character indicates that it's a new line. If you want to break the line manually, instead, so what we do is we use this cat function. Okay, so what now it's going to do is it's going to use this backslash n and automatically insert the new line. So if you execute the code, bada boom, now you see that all the text is in a much better way. So the previous answer, when we just use the string, it's going to print the whole string together. So instead of adding that new line, it printed a symbol called backslash n. So it just confuses a little bit that why is this a backslash n? Because this backslash n indicates a new line, and new line has this backslash n hidden character. Okay, so if you want to print it as a normal thing, you use this cat function. The cat will automatically read the new line and add an actual new line in your output. Okay, so this cat function does this thing for you. So it will read the new line backslash n and actually add a new line and remove this backslash n from your output. Hence, you get exactly what you write. Okay, so the output is in much cleaner form. So whenever you need to use a multi-line content or multi-line text in your output, make sure you use this cat function. Then we have some other built-in functions that we can use with the string, such as length. The length function will calculate and count the number of characters in your string. So it depends on how big your string is. It will automatically go and count each single one character and return to us the total number of characters in your string. See, so this is returning 12 to us. So we use this n character function. So it will calculate the length of this string or the number of characters in the string. So n for number of characters, a function built in, you pass it str as an argument inside the round brackets. What it's doing now is it's calculating each one character, counting one of them, each one, including the space. Do mind that space is a character without any physical representation. So we have a space as a character. This will also be counted, and then the rest of the words. Okay, so n character, very cool function that allows us to calculate the number of characters in a string. Then we can use another function called grepl. Grepl function is used to check if a character or a sequence of characters are present in a string or not. In other words, it is used to find or search something from your string. So whenever you need to search something from your string, you use this grepl function. What it is doing is, for example, we have a string called hello world. We use grepl function. We provide the character h, which is the indication that I want to find the index of this basic number. I want to know whether this h, capital H, exists in this string or not. So we use h, comma, string. So now it's taking two arguments. The first argument is the string that we want to search, comma, and then the string from which we want to be searched from. So in this case, the str variable. So we pass it the str variable, we give it a string, and then it finds the string. So if I execute the code, you will find that it returns true, 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 or false, indicating that whether this h exists in this string or not. If it does, it returns true. If it doesn't, it returns false. So in this case, grepl uses x. Is x present? So obviously it's not. So it returns false for us. So using grepl, we can very easily do a small searching to determine whether a sequence of characters or a single character exists in any given character or not. Similarly, we have a function called paste. What paste is doing, it is allowing us to merge or concatenate two different strings together, forming one single string. To do that, we have a string called str1 hello, and we have another string called string2 the world. Right? So we use a paste function, and it copies and pastes both strings together in one single string form. So if you execute the code, the output would be basically two strings combined together. We get hello world. Okay, so the hello world became possible because we used the paste function to combine two strings together. Make sense? A little bit, right? Yeah. So this becomes few straight. So this is few functions that we can use with the strings. Again, you can check the reference library and find out many other functions that are available for the strings as well. Let's talk about booleans now a little bit. All right, Boolean or logical values. Okay, so Boolean basically determines us that whether the value is true or false. So you often need to know if the expression there is either true and false. Even though, if for example, in this case, when we return the true and false, so this true is actually a value that was returned from this grepel function. So the system or the processor needs to know what type of answer I got. The answer either in this case is true or false. So this is also a type of data. A data that holds either true or false. So even the processor needs to know that what type of answer we are getting. So that's why we use Boolean, and it's very important, very useful. So you can evaluate any expression in R and it gives us answer in form of true and false. But expression evaluation means just like we did here, we asked grepel function to find out whether this string exists or not. If it does, it returns true. This true is of type Boolean. Or we will use this same thing within operators, if else, while loops, for loops as well. So they all use expressions to determine few things. Based on those expressions, they make a decision. So those expressions need to be in form of either true or false. Okay. So for example, we have examples of few expressions written here. What we have now is 10 greater than 9? Okay, so this is a greater than symbol, a arrow indicating that the value on left hand side is bigger than the value on the right hand side. So it's determining if this is true or false. This is called a logical expression. So since 10 is bigger than 9, the answer would be true. Similarly, we can write double equal to sign. The single equal to assigns a value, but the double equal to operator does a comparison. It says, is the value of 10 equal to the value on the right hand side, which is 9? This will return false for us because again, they are not equal. Again, do remember you can use values or variables for that matter as well. So you can compare two variables as well. Similarly, we have 10 less than 9. Again, the value is false because 10 is bigger. So the less than will be that the value on the left hand side is less than the value on the right hand side. If you execute the code, you would get the similar output. See, true, false, false. Okay, so 10 is bigger than 9, we got true. 10 equals to 9, we got false. 10 less than 9, again equals to false. So you can use comparing two variables value as well. So for example, I have a variable A containing the numeric 10. I have a variable value B containing the numeric value 9. So I can use if A is bigger than B. So you can easily compare variables, values as well. You can also run a condition in an if statement, which will basically we will learn later on, but this if condition is used for comparison. It determines that whether value is true or false. Based on that, it makes a decision which line of code to execute. So it creates that non-linear diversion within your code. Okay, so here, for example, we have two variables value called 233. So we check whether if the value of B is greater than A. If it returns true, the if block will execute. If it returns false, the else block will execute. That way, we can control which type of data is executing. Make sense? But more about this in if else as well. So the only thing to keep in mind is this Boolean thing. Okay, wonderful. We have been talking about R programming and we have used various different concepts already. We have discussed various different concepts already. We have talked about the basic introduction of R programming from syntax, variables, data types, math, string, and the last session covered the booleans. So this is the third session using W3Schools website as a reference material. We're going to continue and talk more about today in operators, if else, while loops, and for loops. So now we had, as we talked about various different data types previously, let's moving on to operators now. What are operators and how we use them? So operators are used to perform operations on variables and values. In example below, we use the plus operator to add together two variables. So for example, we have 10 plus 5. So this plus is known as an operator. Makes sense, right? And these operators allows us to perform various different operations on variables and values. as we go along. So in R, there are basically various different types of operators, from arithmetic operators that involves plus, minus, multiply, divide, self-explanatory. We have assignment operators, we have comparison operators, we have logical operators, and we have miscellaneous operators. Arithmetic operators. Well, arithmetic operators are used for numerical values to perform various different mathematical operations on them, and we have already used with them. So in R, we also have same thing. We can use plus, minus, multiply, divide, exponent, modulus with a double ampersand sign and percentage sign, and then we have integral division as well, depending on how we use them. Now, if you look at the plus operations, well, it's self-explanatory. X plus y will give us the addition, subtraction, x minus y, x multiply y, and divide, and so on and so forth. Same goes with the exponential notation, modulus, which basically gives the remainder divisions, and integral division as well, that has this division sign at the between as well. So we have 2% sign will give us modulus, but then if you use the division, it will give us an integral division. Okay, so these are self-explanatory arithmetic operators. I don't think so we have to delve too much into them. Then we have something called assignment operators. Now in R, we have already talked about that in order to assign a value to a variable, we use this arrow sign. Okay, so we can use my variable double arrow sign minus, we can use minus arrow sign to this variable. So this basically means that we are assigning the value of 3 to this variable, or we are assigning this variable values to this 3. Basically all mean the same thing. So this double arrow or a single arrow represents that we assign operators to itself. So if you run the code, you would see that the variable 3 gets printed. So no matter what you do, this my variable has a variable 3 assigned to it. Okay. Similarly, if you go that if you understand that this double variable is a global assigner, you will learn more about this in global variables chapter later on, where we discuss with that. Okay, so it's also possible to turn the direction of the assignment operator. So you can use this direction or this direction as well. Make both are exactly same in R programming. Now let's talk more about the comparison operators. Comparison operators are what we call the logical operators. They allows us to logically evaluate a condition and return true and false to us. So whenever we use double equal to, this basically means that we are trying to evaluate a condition whether the value x is equal to the value of y. So this is what we say a comparison operator does. It compares the value of two variables and returns either true or false for us. Then we have not equal to, which does the inverse. The value of x is not equal to the value of y. Okay, again, either true or false will be returned, Boolean data type. Then we have a greater than symbol, which basically means that the value of x left hand side is greater than the value of right hand side, y value. And then the less than will basically mean the value of x is less than the value of y. And then we have greater than equal to, which means that the value of x is greater and equal to. So the condition means that it can be greater and equal to the value of y. And x is less than or equal to y. Okay, so we have the same thing, greater than or equal to, less than or equal to. So these are what we call a comparison operators are. They give us a comparison or an evaluation of logical values between two operands from left hand side to right hand side. And the answer, keep in mind, is always in form of Boolean. Okay, they always return either true or false. This is where we start to use them in if else and also within the loops as well. And then let's talk more about logical operators in R programming language. What are logical operators? Well, logical operators are operators that combine multiple conditions together. So in previous here, we only check either x or y. So one condition is evaluated, x is equal to y, or x is not equal to y, or x is greater than y. So this is a single condition. Using logical operators, we actually combine multiple conditions together. Okay, so for example, when we want to evaluate whether the value is smaller than something and at the same time bigger than something else as well. So, or we're defining a specific range as well. Okay, so whenever you need to use that, we basically use these logical operators that combine the conditional statements. So we use these conditional operators and combine them. We'll talk more about them as we go along. Okay, we'll see more examples. So we have AND operator, which is basically element-wise logical AND operators, returns true if both elements are true and false. So for example, let's just check the example here. So here we are checking 5 is equals to 5, which returns true and false. 5 is equals to 3, which returns false. But at the same time, you can use AND operator, and then you can say, hey, what about 3 is equal to 3? So now what happened is that we have used condition A and condition B. So we want to ensure that both the conditions once are satisfied, only then we get the answer either in form of true or in form of false. So now you get false. Why? Because 5 is not equal to 3. So because this first condition becomes false, the answer becomes false at all. Because the logical AND operator has to ensure that the both conditions are true. So if it will return true if both elements are true. So what this actually means is that now we are trying to evaluate both two different conditions. So this is where the logical operators come into play. Conditional operators, they only evaluate one expression. Here we are evaluating two different expressions, and then you can concatenate as many expressions as you want. So you can have another expression here evaluating, for example, 5 is less than equals to 6. So this also becomes a perfectly valid reason. So now we have three expressions. So these logical operators allows us to combine and evaluate multiple conditions at the same time. But the condition being that this result has to return true, and this result also has to return true in order for this entire expression to be true. If any one of them becomes false, if this is false, the whole expression is considered as false. If any one of them becomes false, the whole expression becomes false. This is where the OR operator comes into play. Okay, so OR operator, what it does is that it needs any one of these conditions to be true. So if you come back here, instead of AND, if you replace it with OR and replace this with OR, so it says that, hey, any one of them, if they become true, I will return the result true for you. Okay, so see, this result is true. Even though 5 is not equal to 3, this becomes false. But it says, okay, because I have OR operator, I have an option. So if this becomes false, it doesn't really matter. Let me check another condition. So if 3 is equals to 3, because any one of them is true, now it's returning true to us. So it doesn't really matter if this is false or true anymore. But obviously 5 is less than 6, this is also true. Hence this expression returns true as well. So the OR operator needs only one of the entire expressions to be true, and has to make sure that all are absolutely true. Only then it will return true. So that's the major difference with that. So if you use double AND operator, so it's a logical AND operator, returns true if both elements are true. And then similarly, a logical OR operator returns true if one of the statements is true. The same goes with that. So you can use a single pipe with double pipe as well. Then we have a logical NOT, returns false if the statement is true. So this actually inverses the result. So it inverses the result, and instead of if true, it inverses the results and makes it false. So sometimes it is quite useful in certain situations as well. Then in R, we do have certain miscellaneous operators that are also used for manipulating data. For example, the colon creates a series of numbers in a sequence. So for example, you can use X assign arrow function 1 to 10. So this is used inside the loops as well. That means that we want to assign series from 1 to 10 to the variable X. So within a loop, it will loop itself and then assign each number to it and use different number every time the loop arounds. We see the example in the loops section. Similarly, we have percent in percent. Find out if an element belongs to a vector. So it uses in terms of searching. Okay, so we want to use that if X belongs in Y. So if this value actually exists in Y or not. Okay, so we use percent in percent. Similarly, matrix manipulation has percent multiply percent symbol. So for example, you can use X belongs to matrix 1, percent symbol matrix 2. Okay, so again, we will try to see a few examples later on in the sections. In matrices specifically, we'll see how we basically use them to get a better understanding how we actually use these in practical life. So do keep this thing in mind as well, that we have these additional miscellaneous operators that we will use later on. Okay, let's move on to if else now. Okay, so coming back to if else. Well, if else are one of the most fundamentally important concepts in programming. They allow us to check conditions of a certain statement. Now, by condition, we means that using if-else statements, we state a certain amount of conditions, and if-else evaluates whether the condition is true or false. Based on that, it makes a decision whether to execute a certain piece of code or not to execute that code. This gives us the power of controlling the flow of our programming. Okay, so in if-else, basically we do use the same conditional operators using equal to, not equal to, greater than, less than equal to, greater than equal to, and less than equal to. These operators allows us to maintain a conditional flow within the systems. They allow us to check the conditions, and based on that, the condition becomes either true and false, and the if statement executes certain piece of code. Make sense? A little bit, right? Okay, so these are something we've already talked about. Now, how does if-else independently actually work? So the way if-else works is that if else is written with the if statement. Again, this if is a keyword, it is a word, bracket start, bracket close, block start, block close. Okay, within the block we write a certain piece of code, 1 line, 2 line, or any number of lines of code you want to write. Now within the if we write a condition, okay, using the same conditional operators that we just discussed. These conditional operators evaluate a condition and return either true or false. If actually needs only true and false. It doesn't need this expression. It needs true and false. If the answer here is true inside these brackets, the block of code will execute. If the condition becomes false here, the block of code is completely ignored. That's how if else tends to work. So this block will not execute if the condition here returns false statement to us. So in this example, what we have done is we have A assigned 33, B has been assigned 200 value. So now we're checking the value of B is greater than A. And since the value is greater than A, the condition returns true. And if reading the true condition executes the block of code. In this case, for example, if you change the value to 333, now if you run the code, see nothing gets printed. Why? Because now the condition is false. Because the condition is false, the block is completely ignored. This is what happens when we talk about if-else statements. So if a statement actually reads a condition, execute it. So in this example, we use two variables, A and B, which are used as a part of a statement, if-else, okay, part of if statement, sorry. So to test whether the B is greater than A or not, we use these expressions. We use assign them the values, and then we use this B is greater than A value. This is what this is all talking about. Okay, so since B is greater than A, it gets printed that B is greater than A. Okay, so R uses these curly brackets to define the scope of the code. So these curly brackets are indicated as a block of code, or sometimes also known as scope in the code, that the scope starts from here and ends here. So the if boundary actually starts from the block of code, starting from this block, ending at this block. So whatever you write inside these two blocks becomes a part of if statement. So if condition is true, everything inside this block will get executed. Okay, then we have something called else statement. Now this is usually goes in hand to hand with if. You cannot write else separately. You have to write if the else statement after the if. Okay, so the if else keyword in R, the way of saying it is that if the previous conditions were not true, then try this new condition. This is how it basically works. So what's happening now is we have if statement. Okay, it evaluates a condition. If the condition becomes true, this block is executed, and everything outside this block, this else, is completely ignored. This will not get executed if the first condition is true. In a situation where this becomes false, now else will execute. So if the if is false, it will execute the else, and then it will have another if inside this else statement. So this will check the condition again and execute the piece of code. Okay, so now let's move on to something called if else. The else keyword itself is used independently as well, along with the if as well. So if you are using the system, you can use else if, or you can simply use if else statement where else is used independent of if. How does that work? Well, for example, if you have a condition if B is greater than A, and then you specify statements that in this case, if the condition is true, you use this, then we use else if. Again, this part is not mandatory, just for an example sake it's written, but here you notice we have only else without any if. Now this basically means that in case both of these statements becomes false, then this becomes the final default execution. If any one of these if becomes true, that particular block is executed and the control gets out. If this becomes true, this first line is ignored. If this becomes true, this line is executed, and this else is now ignored, because again we have already a true condition here. These lines will get printed. This if is completely ignored. However, if none of them is true, both this if returns false, then we go to else. If again condition is checked, if this becomes false, then again we go finally execute the default else statement. So you can write else in the simply as a separate statement as well, but yes, else cannot come absolutely independently. So you cannot just write else. Else has to be written after a given if statement. So it has to be a statement that you write after if. So in this case, again, after this if, we have an else statement. Okay, so you hope you understand that. So now let's talk see another example. So in this case, you see we have two variables. We write if statement, and then there's an else statement. So as I mentioned, that this part is not necessary. It doesn't mean that else has to come after every else if statement. It's basically after every if statement. So it does comes after if statement. So technically this else is part of this if, means that if this if becomes false, this else will execute, and there's no condition here. Means no matter what if the control comes to this else, it will execute this statement. So in this case, you can write it simply in this manner as well, where you write if and else statement. If condition is true, execute this block. If the condition becomes false, go here and execute this. So there's no separate condition here to evaluate. This will become like a default statement in case if any of the above statements becomes false. Make sense? So this is what if-else statements allows us to do. Then let's talk more about the nested if-else statement. Well, what do we mean by nested if-else statement? Nested if-else simply means then when we have if inside another if statement. So in this case, you can clearly see we have if statement. So we write if block start and the block ends here, and inside this if we can write any legal statement of our language, which basically means since if itself is a legal statement, inside the if statement we print something statements, and then we have another if statement to further evaluate a certain conditions. So if x is greater than 20, print the statement else. If this becomes false, print the else statement block in this case. And then the block ends here. So this if blocks actually ends here. Then with this if we have another else statement, meaning that this else is actually part of this nested if else structure where we have if inside another if, and then it has else, and then the control comes back from this block here, and then this else actually belongs to this f. So for example, if x value is less than 10, and then you execute this, so this code becomes false, right? So for example, if x is only 4, right? So if x is only 4, we say this condition becomes false. So all of this block is completely ignored. None of them will be executed because the condition is false, and the control will automatically be transferred to the else statement. Hence, only this line will get printed. Make sense? This is what nested if-else means. So basically, you can nest multiple if-else inside each other and do a more comprehensive if-else comparison or conditional comparison in your case. Okay, so this is all basically what the logic of if-else does. In this phase, we're going to talk more about while loop. If you're here for the first time and still haven't subscribed the channel and interested in learning programming language with me using W3Schools as a reference website, well, please do subscribe. Leave your comment below what you are learning, what you want to learn next. Helps us a lot. Okay, so without further ado, let's begin. Now, let's talk more about our while loops. Loops can execute a block of code as long as a specified condition is reached. The way the loops work is that they repetitively cycle through your code, the same block of code again and again until a condition is satisfied and becomes true. As soon as the condition becomes false, the loop breaks and stops the execution. It is different from if-else because if-else again also checks the condition, but if condition is true, if-else only execute once. The way the loops work is if the condition is true, they execute the block and the code is again repeated. Check the condition again execute the block. So it's a cyclic motion. It keeps on repeating itself. That's what basically loops does. In our programming, conventionally, we have two types of loops. We have a while loop and we have a for loop. Let's go more into while loop and then we'll talk for loop later on. So these two loops are primarily used in our programming language. How the while loop works? Well, in order to use the while loop, what we need to do is we use a keyword called while, bracket start, bracket close, and then we specify a condition, again using the same relational operators that we have talked about in previous sessions. Okay, so we use I is less than 6, means we check a condition, then block of code starts. Again, similar to if else, while loop also has a block of code. Anything you write inside this block will be considered as a body of while and will repeat itself until this condition becomes false. Okay, so then it prints the value of I. Then here's the key step: we increment the variable. Now this loop has three major parts that needs to be understood for the loop to work properly. Every loop, either while loop, for loop, same goes for every other programming language as well. Every loop needs to have a variable. Okay, we initialize a variable, then this variable is used as a conditional evaluating parameter. In this case, I is being used as the key parameter that is being evaluated here. Then third part is the increment of that variable, so that at a given point this condition becomes false. If we don't do that, the condition will remain true forever and the loop will keep on repeating forever and it will become an infinite loop. That's the pitfall of using loops. So we have to be very careful about that. Again, every time you use a loop, just have these three benchmarks. Initialize a variable, use it inside a conditional operator, and then use it to increment the variable value as well. So we increment it, then we check the condition, print the statement, we increment it, check the condition, print the statement. That's how the loop works. So here I belongs to I plus 1. So what we're doing is we're taking the current value of I, add 1 to it, and then assign it back to the value of I. In other programming languages, you can use x plus plus, the simple increment operator, decrement operator. Again, the same thing. In our programming, we've talked that we use this arrow function less than minus sign as an assignment operator. So here we are assigning the current value of I, add it with 1, so plus 1, and then assign it back to the I variable. Make sense? So this is how the loop works. So if you execute the code, see, we get multiple lines of statements being printed. That's one of the primary outcomes of a loop. What it does is it allows us to print multiple statements using the minimum code. Okay, so here we are printing up till 5 using these 5 lines. So if we change this to, for example, 1000, now the same code will actually repeat itself 1000 times until the value of I becomes, sorry, not 100, 1000, until the value of I becomes equal to it and the condition stops. So this is what the loops do. It allows us to repeat certain piece of code multiple number of times in the minimum written form. Make sense? Perfect. So now again, what's happening here is the first thing we do is we initialize a variable. So I is being initialized with 1. Then we use the value of I and we evaluate a condition here. So in this case, if I go back to my original value 6, wow, now what we're doing is we're taking the value of I is less than 6. So we're checking a condition. Is the value of I less than 6? The condition becomes true. The block executes. Within the block, we print the value of I, which initially is 1, okay, because we have initialized it 1. Then we increment the value of I. So I plus 1 becomes 2, assign it back to the value of I, and then because this is a loop, the body will automatically re-execute. Again, check the condition. Now I becomes 2 because we just did the increment inside the block. 2 is less than 6, condition becomes again true. Print the value of I, do the increment, now becomes 3. 3 less than 6, condition becomes true. Print the statement, do the increment, 4. Then again 4 less than 6, true. Again print the statement 4. Then go back here, do the increment, value becomes 5. Then again I is less than 5, condition becomes true. Print the value of 5 from here, do the increment. Now it becomes 6. Because now it becomes 6, this condition becomes false. I is 6, less than 6, condition is false. The loop breaks, no more execution code. That's how the loop works. Okay, so remember to increment I or else the loop will continue forever. So this increment statement is quite important. If this doesn't change the value of I, the value of I will actually remain same forever. And then that will mean the loop will run forever. Then within the loops, we use something called break statement. Now, break statement, we can stop the loop even if the while condition is true. It is used in a certain condition to abruptly stop the flow of a loop. So for example, if you're searching, as soon as the word is found, no longer need to search the remaining content, just break the loop. Makes sense, right? So this is what we're trying to do. So if I have I is 1, I is less than 6, print the value of I, do the increment. Now check if the I is 4, break. So if the condition is satisfied, just do the break. What break will do, it will stop the execution flow. So if you execute the code, you would see that the value only prints up till 1, 2, 3. As soon as the value reaches to 4, it breaks and the execution stops. Even though the condition is 4 less than 6, this is true, but because we have used the break statement, the statement breaks here. This is quite feasibly and quite popularly used, especially when we're doing searching or trying to find something from a fair files or data, or whether certain benchmark has already been reached. So while allows us to cycle through a bunch of data, but if we found a data or we have a certain benchmark, just stop it there. To do that, again, we use a break statement to break the execution flow. Okay. Similarly, we have a next. Next statement, we can skip an iteration without terminating the loop. So for example, if we want to skip certain outputs from the code, again, if there's a character that we want to say, hey, if you find this character, just skip it. If you find this variable name, just skip it. If you're doing some searching, if you find this character, just skip it. In that case, we use the next statement. This is equivalent to continue in other programming languages. So if you are familiar with Java or C# or Python for that matter, they all have a statement called continue. In our programming language, we use something called next. So the way it works is, again, we have to use it with the if block, same as the break statement. They also need to be in if, so that when a condition is met, it breaks it based on the condition. Same goes with the next as well. But what it does is that when it prints it, it will start from the value 0, prints the value 0, then prints 1, then prints 2. As soon as it reaches 3, it just skips the 3. So if you execute the code, you will notice we have 1, 2 and 3 is missing. 3 is missing because we use the if I is equals to 3, go to next. What this does is it doesn't go to this line, it actually jumps from next back to the condition. Okay, so anything that you write after next will not be executed. That's why now we have print afterwards after we have done the increment. So here what we're trying to do is we are printing the statement at the end, and then we are using the skip or the next statement before the printing statement. So if the value by I is met with respect to 3, just skip that value, don't print it. Okay, so this next allows us to do that. Hence we have that value skipped here. Make sense? A little bit, right? So this is wherever we need to do that, basically we go with that things. So if else combined with the while loop. To demonstrate a practical example, let's say we play a game of Yahtzee. Print Yahtzee if the dice number is 6. Okay, so if dice value is 6, so in this case we are not using a random value, just take a value 1. So while dice value is less than 6, because again it has to be less than equal to 6, if dice is less than 6, print no Yahtzee, else print Yahtzee, dice plus plus 1. So whenever the value of variable reaches to 6, it prints Yahtzee things. Okay, so if you use it, it will just simply do that. So if the loop passes the value ranging from 1 to 5, it prints no Yahtzees. Whenever it passes to the value of 6, it prints as Yahtzee. Same as that. I think stupid game, but it's there as an example for W3 schools. Make sense? Perfect. Let's talk more about for loops. Okay, so now talk about for loops. Well, okay, so loops also work with similar to while loop, that they execute certain block of code again and again and again and again. However, this is difference in syntax and how we write the condition statement. For loop is used for iterating over sequence. That's the primary purpose of a for loop in our programming language. What for loops does is that it allows us to control the iteration over a particular sequence of characters, over a list, over a data, over certain big, for example, loops for lists or sets or dictionaries, something that has a sequence of characters inside it. Okay, so what it does is that we use the for loop, x in 1:10 print x. Now what's happening here is, let's debug this a little bit. So the for loop again is a loop that will reiterate itself or continuously cycle through this print statement until this condition is satisfied. Okay, so this is the key part for the for loop. So you see, it's not simple as in the while loop. It has a little bit typical syntax. Let's break it down. First, the condition 1:10. What this is what we call a sequence. This basically is known as a range. So what we're telling it that start from 1 and up till 10. So this colon here is indicating a range of characters, or in this case range of numbers from 1 to 10. Okay, then we are using the in keyword here. So technically in more other programming languages, it's also known as for in loop. Then we have the x variable here. So there are three main things. We specify a range, we use an in keyword, and then we use a variable here. What's happening here is that the for loop or for in loop specifically is quite powerful. It does multiple tasks using this simple single line of code. What it is doing is, first is specifying the range using 1:10. Second, it is saying that read the first element from this range in this range, because using this in keyword, it is reading this in keyword. And then in this range, read the first character, assign it to the variable x. Okay, so see, these three things are happening. Range is being specified, reading the first character using the in keyword, and then assigning it that to the x variable. And then we print that x variable, hence it prints 1. Then again go back to the loop. Now because we have already printed 1, the in keyword automatically will traverse to the next item in your list or in your sequence. So now it will take two character, assign it to the variable x, and the value is printed. Then again go back to the loop, take character 3, assign it to the x, print the variable x. Similarly, up till 10, assign it to the variable x, overriding its previous value. So whatever previous value was, override it and then print it. So it will print us between 1 to 10 values. So if you execute the code, you would see that we'll have 1 to 10, even though there's just 3 lines of code. How it's working? This 1:10 is actually specifying a range of characters from 1 to 10, range of numbers, in fact, sorry. So what we do is we specify the range, then using this in keyword, we traverse through this entire range. So it reads the first number, assign it to the x, reads the second number, assign it to the x, reads the third number, assign it to the x, overriding the previous value, the value of x is printed until we reach the end of the sequence. And then that end is also marked by the in keyword itself. So the in for automatically knows, hey, we have reached the end, hence the condition becomes false, just break the loop now. So after 10, because there is no more range, the loop will automatically stop. So it prints from 1 to 10, a complete sequence. Now this can be your array, this can be your list, this can be your enumerations, your data, your Excel file, whatever data, your range of sequence you are reading, basically you can read that using this simple for in loop. Okay, so we'll talk more about lists and vectors in next sessions, in other sessions where we talk about these data structures here. So do keep tune in. Okay, then let's talk about the break statement. Again, yes, similar to the while loop, the for loop also has a break statement. So if you are looping through a certain list, so for example, in this case, we have created a list of items using R programming. Here, the list is apple, banana, cherry, 3 different items, comma separated. Okay, so comma separated, apple item, banana item, cherry item assigned in a list, and they have been given a name called fruits. So now we want to traverse through this list of items, okay, or we want to loop through this list of items, print each item individually. We can do that again, same for x in fruits. So now instead of giving a range 1 to 10, we are passing it a list that contains actually multiple items inside it. So now we're saying, hey, go inside this fruits list, read the first item, assign it to the x. Then next time, again, if you print it, then next time go back inside the lists, fruits lists, fetch the second item, assign it x, overriding the previous value, print it. Then go back into the list again, print the third item, assign it to the x, overriding the previous value, print the item of x. And then it works. But because we have used break here, so we're saying as soon as you find cherry, just break, do not print it. So this will again stop the execution flow and the for loop exits. So in other case, if you have found the word cherry, just break it. So we can have some other statements, hey, character found, and then just print it out. Make sense? Similarly, the next is also there. It skips a beat. So if you want to print a statement, see, banana is not printed because we are saying, hey, loop through these fruits. If you find a banana, just skip it. I don't want to see the banana as an output. So if you want to skip certain words out from your selection or from your sequence, this is the one way of doing it. That print all items except banana, or there can be many other items as well, depending on what you want to do. So the next will actually skip an item, but it will continue the loop. The break will stop the execution flow and end the loop completely. Okay. Same thing goes with the Yahtzee game. I don't want to say this, just go through it. Make sense? Let's go for nested loops. Now, nested loops basically means loop inside a loop, and they become sometimes very tricky and sometimes very, very useful. The way they work is that we define a list 1 or any other sequence for that matter. We have another list called fruits. So we have adjective and the fruits list. Then we say for x in adjectives. So first read through each item of this. So read the first item, which will be read, assign it to the variable x. Then inside the body, we have a for loop. Okay, so we say for y in fruits. So now read the first item of y in terms of fruits, first item of fruits, assign it to the variable y. Then paste means paste the value of x and paste the value of y inside the print statement. The output will be quite interesting. Now you see, we have a bunch of data. What's happening now? Let's debug that. The way the nested loop works, that for every single iteration of an outer loop, the inner loop completes its entire cycle. So for example, if there are 3 items, for every single item for the outer loop, the inner loop will execute 3 times based on the number of items inside its list. Then again, for second item, again it's going to execute 3 times. Then for again third item, tasty, the inner loop will again execute 3 times for its items. Hence you would see red apple, red banana, red cherry. So actually red is being fetched only 1 time in the x variable, but the fruits y is actually being executed 3 times. So we have red, we have banana, and we have cherry. Similarly, if you go for big, now again for the next item, again the loops executes 3 times. So big apple, big banana, big cherry. Again then tasty, so we take 1 item, outer loop, inner loop executes 3 times. So outer loop actually executes only 3 times based on items that we have here. But inner loop has executed 9 times. based on that for every single iteration of outer loop, the inner loop executes 3 times. Then again single iteration, again inner loop executes 3 times. Again single iteration, again inner loop executes 3 times. So the outer loop only executes 3 times, inner loop executes every single time for the single item. So it executes 3 times. That's what the nested loop basically allows us to do. Okay. So sometimes a little tricky to understand, but the basic idea is that we have a loop inside a loop. Every loop will complete its cycle and then relinquish the output or relinquish the control. So when this loop executes for the first time, this loop will come into control and it will complete its entire cycle before the control goes back to the outer loop. And when for the outer loop's second item, again the loop will execute, because do remember that looping means the same statement gets executed again and again. So the statement in this case, because they are looped, they will keep on iterating until the cycle is complete. Then again control goes back to the outer loop. This executes third time, and coming back here, this will again execute multiple times. So that's how the loops tend to work. Make sense? Perfect. Finally, let's round this session off with understanding how the functions tend to work inside the R programming language. Well, typically a function is a block of code which only runs when it is called. It's a block of code that performs a specific task. We use function for wherever we need certain block of code to be executed again and again and again. Okay, so for example, if you are doing addition, you know that if you're building a calculator, the addition is going to be done again and again. So we use a function and we put the addition function there. So that every time you hit the plus, it reads the two values and gives us the answer back. So you don't have to write the code again and again. We have a function that does the task for us. Same goes for every other mathematical operation. So a function typically is a block of code which only runs when it is called, and you can call it as many number of times as you want. You can pass data to it, known as parameters, into the functions, which they can use and do calculations or operations on them. Functions can return a value as a result, return a value in terms of answer. So when they perform a function, they can give us a reply or give us an answer. Okay, so how do these all operations work? Well, first step is creating a function. To create a function, we use the function keyword inside our programming language. So we say my function. Again, this is my function name. So I give a function name. Any name is legitimate as long as there's no space between the name. Same variable rules actually apply here. So make sure it's all small case or camel case, and then it has underscore but no special characters, or doesn't belong with doesn't start with a number as well. Okay, so the number can be later on in any word, but should not be the first character, should not have a space. So we use a function name, which is my custom function name. We use the arrow function, similar to assigning a value. We assign it a function. So this is basically, and you can assume that this is a variable, but instead of assigning it a value, we are assigning it a function. So now the function is basically being assigned to this variable. Hence, this becomes a function now. So it also, because this is a function, every function has a block of code, an ending block of code, curly brackets, and then we write a bunch of lines here that can perform a specific task. Okay, so this is how we execute the function. Similarly, once you declare a function, then you need to call the function as well. To call the function, use the name parameters. So for example, we use my function, arrow function, and then function itself, the keyword, block start, block close, we have a print statement. That's a typical sentence of declaring a function. To call a function, we use the my function, and then this time only use the parentheses. No longer needed, all of these operations are omitted out. So we use simply my function, parentheses. Now notice we use print. It has the similar syntax because print also is a function and it performs a specific task of printing whatever we write inside here onto the console. Okay, so this is what we're doing. So now we are declaring our own custom functions. So this is called function declaration. This is called function calling. We can call this function as many number of times as we want. Every time we call, it will go and execute the block of code. But to make more sense, we use arguments. Arguments are basically information that can be passed to the function. Okay, so we specify arguments here inside the parentheses. You can specify one argument or multiple arguments for that matter. As many arguments you specify will actually be passed to this. Hence, you need to receive those arguments here as well. This is called parameter now. So this is argument passing. This is called parameter receiving an argument, interchangeably actually used. So what now we're doing is we're saying, hey, I have a variable called fname. So when you pass it an argument, this Peter will be assigned to this variable. Because I'm calling my function with an argument called Peter, this Peter will be assigned to this parameter now, this variable f name. And then I can use paste function to use the f name and then provided some other valuable information here. So if you run the code, you will find that it prints Peter Griffin or Lewis Griffin or Stevie Griffin. So you are calling your function multiple times, but every time you call, you are giving it a different argument. Okay. So if this can be your addition function as well. So you can have 5 plus 5, 5 plus 7, or whatever operations you're doing. So the add function will have different number of arguments. Every time you just pass the arguments, it will take the arguments value, do the operation, and then return an answer to you. Okay. So this is what function is. So now two terminologies, parameters or arguments. As I said, in my understanding, we just use it interchangeably. But typically we say when we pass a value, when we call a function, this becomes an argument. And here, this is basically known as a parameter. That's the major key difference between it. Okay. So number of arguments, obviously, as I said, you can pass multiple arguments as well. So here we are passing multiple arguments. We are saying f name, comma, l name means that we're telling it, hey, this function has 2 arguments. So because we have specified 2 arguments here, when we call the function, I have to ensure that I do pass it 2 arguments. In this case, because I declared only one parameter here, hence only one argument is given. Okay. And in this case, we have 2 parameters. Hence, when I call the function, I need to ensure that I pass 2 arguments. So when I say Peter will be assigned to the first f name, the second argument will be assigned to the second parameter automatically. And then we can use f name, l name in the paste function to paste the values of these 2 parameters. Okay, so if you don't pass it 2 arguments, this will generate an error. So for example, if my function takes 2 parameters, means this is the function declaration. We have declared that my function has to have 2 arguments. But when you call the function, you only give it 1 argument. The second one is missing. Hence, the R programming will get confused and it will only print error here. Because hey, he say, I need 2 arguments, you're just giving me one. So that just creates a problem. Similarly, in arguments, there's something called default parameter value as well. Okay. What this will basically mean that in case where you are not sure whether you will be passing 2 arguments or 1 argument, you can set these arguments with the default value just to ensure there is no errors and ensure that the error debugging can be done easily. Okay. So in case the arguments are missing, there's still the default value. So it's a fail-safe mechanism. To do that, we use country is equals to Norway. Notice we are using equals here, not the arrow functions for some strange reason. Technically should be an arrow reasons because all this time we have been using arrow functions. Anyway, some strange thing happens every time. What we're doing now is we're telling it, hey, listen, I have a country variable equals a default value of Norway. Then I paste the value of country here. So if I call my function Sweden, it will use my function Sweden. If I say my function India, I'm from India. If I don't provide an argument, if you don't use this default value, this will generate an error because it says, hey, I need a parameter. You have not specified the parameter. But because I have used the default parameter value, even though I have not specified any argument here, this will go and print the default value called Norway. And that's what the fail-safe mechanism basically means and allows us to have, that you can use a default parameter with a default value. In case if the value is not passed, still it will run and use the default value in that case. Finally, the key thing within the functions is known as return values. To let a function return the result, we use the return function itself. What this basically means is that I have a function, it performs a specific task. After completing its task, this function will return a reply. This function will give us an answer. That's the key point here, that whenever in previous examples here, there's no return function. So when you execute, there's nothing printed here. There's no return answer coming from here. However, in this case, we use a return, bracket start, bracket close. Inside the return function, we say, hey, 5 multiplied by x. So whatever the value of x is given as an argument or passed through this parameter will be used and multiplied with this. But this will not print the output. In fact, this will return an answer for me. So it says print my function 3. So now we have used my function inside the print statement. Why we have done that? Because again, first thing, my function. We pass it an argument called 3. Argument will be assigned to this parameter. It does the calculation, but then it returns a reply. Because this is returning a reply, I need to receive that reply. Hence, I've used this my function inside the print method. So whatever reply comes from my function gets printed on the console. Whatever reply comes from my function gets printed on the console. Whatever reply comes from my function gets printed on the console. So the output will be 15, 25, and 45 respectively. Understand? So the return function allows us to always ensure that when this function executes, it returns a reply back to this calling function. So whenever we call the function, it will receive and it will be getting a reply back. So because it's receiving an answer, we have to have a mechanism to receive that reply as well. Okay, so we say we put this in print method. Okay, or this can be another variable for that matter as well. So when whatever answer is returned from here can be assigned to another variable for that matter. Make sense? Perfect. Okay, so I think that concludes the basics of R programming. We're not dwelling into too much detail now. In next sessions, we will try to go as much detail as you can. So, but do let me know in comments how far you have reached and how much are you interested in going into these further topics, so I can actually make the videos. So if nobody's interested, I don't want to delve into something of that sort. But yes, so if you have completed up till this point, followed all the 5 sessions, excellent. Thank you very much for watching that long. And do leave your comments. Let me know what you're thinking. And then if you're interested in the next chapters, please let me know in comments so I can actually have a motivation to create these videos much quickly. Other than, if not, I will just keep on creating them on my own pace. So it might be a little bit delayed. Okay. So thank you for watching. This is Dr. Zishan signing off.